next quiz. All right, so this first denominator is called a what? Difference of squares. Okay, so what shows up? X plus 8, x minus 8, you write down, right? So our common denominator is that. Do not factor the numerator yet. Oops. I told you don't do any factoring of numerators till when? To the very end, right? You guys were listening, that's good. Okay, so there's the original first denominator. Here's our common denominator. Did I do anything to it? No. So do I do anything to that first numerator? No. All right. What did I do to this second denominator?
Multiply by x minus 8.
Correct. So I have to multiply x minus 4 times the same thing. Questions on the start? All right, so I have to FOIL the second denominator or numerator. I'll get x squared minus 8x for outside minus 4x for inside plus 32 for last. Okay, so I'm going to rewrite this. Numerator, my denominator will not change yet. It might at the end. All right. So what is a 2x squared minus 1x squared? X squared, right? Or 1x squared. All right, this is a negative 12x, right? So what's nothing minus a negative 12x? Positive 12x, very good. What is 64 minus 32? 32. Are there factors of 32 that add up to 12? Yes. What are they? 8 times 4, right? Any factors that are the same? X plus 8, right? So my answer will be x plus 4 up top and x minus 8 in the bottom. And what are my restrictions? 8 and negative 8. Okay? This is another practice one for subtraction of two rational expressions. Simple. All right. We did number 3, right? Negative 2x minus 7 over 4x plus 5. X cannot equal negative 5/4. What do we do next? 11? Okay. Negative 1 over x minus 4. X cannot be plus or minus 4. 14 is 3x minus 7 times 5x minus 6 for the top. The bottom, the denominator is 4x plus 5 and 6x minus 1. All we had to do was flip it and then just write them. There was nothing we could factor, nothing we could cancel. That was a really easy one. 15, you have to add those two up top first. 2 over x plus 1 over x, which would be 3 over x, right? Already had a common denominator. Then it's 3 over x times x plus 2 over 2x. And your answer is then 3 times the quantity x plus 2 for your numerator and 2x squared for the denominator. Then we jump down to what, 29? All right, you had to factor that x squared minus 4 into x plus 2 and x minus 2. And then you could factor the x squared plus x minus 6 into x plus 3 and x minus 2. So it looks like the x minus 2's would go away. So your answer is, let's see, 29, right? 3x minus 2 times x plus 3 for the top, 5x plus 1, and x plus 2 for the bottom. We don't have to worry about restrictions. Number 30, you have to add the x plus x over 3 first, which would have been 4x over 3. And then you would put x over x plus 1 times 4x over, 3 over 4x. I gotta flip it. So your answer is 3 over 4 times the quantity x plus 1, because the x's would have canceled. 35 is 5x minus 9 over, there's three binomials for our denominator, x minus 5, x plus 4, and x plus 3. So x cannot equal -4, -3, or 5. And then the last one, 40, was negative x squared minus 3x plus 46 for the numerator. If you factored out the -1 in that numerator, you could have. And then you would have had -1 times the quantity x squared plus 3x minus 46. So either way is fine. The denominator is x plus 8 and x minus 4. So x cannot equal -8 or 4. Any of those at all you'd like me to go over? That.
Can you do 29?
29. All right. So the first fraction, the top one, 3x minus 2, the x squared minus 4 would be x plus 2 and x minus 2. I just factored it right away. It's a difference of squares. You with me on that? Okay. And then I'm going to write it as multiplication because I have a fraction in the bottom. So times, and the 5x plus 1 will stay in the bottom. And then this one's going to be x times x for the x squared part, and 3 times -2 for the -6 part. When I add those, I get the +1 part in the middle. Okay? You follow?
Mhm.
Okay. Now, I see an x minus 2 and an x minus 2, top and bottom, that I can cancel. So my answer is 3x minus 2 and x plus 3 for my numerator. And my x plus 2 and 5x plus 1 for the denominator. Couldn't factor the 3x minus 2, couldn't factor the 5x plus 1. So that's what it ends up being. Anything else on that?
If you FOIL the numerator and the denominator.
That's okay. Yeah, it's still okay. You don't have to, though. Any other questions? Is there them? Go ahead. 30. 30. So I got the x over x plus 1. And I'm just going to write it times, and I'm flipping the second one. Oh, it's x plus x over 3. So I got to do this problem first. Okay, so what's the common denominator going to be? 3. Whatever shows up, you write down, right? So, you can think of this as x over 1 if you want. So that didn't change. What did I do to the 1 to make it a 3? Multiplied by 3, right? So that becomes a 3x. You with me there? So then 3x plus x would be 4x over 3. Okay? So that's the answer to that problem. So when I put it here, I have to flip it. Okay? So I can cancel that x and that x. So my answer then would be 3 in the top and 4 times x plus 1 in the bottom. All right, so when you have one of these complex fractions, if you have an addition or subtraction problem as the numerator or denominator, you gotta make it a single fraction first. You gotta add or subtract first, then multiply by the reciprocal. All right? Okay, today, we're doing rational functions. We're gonna graph. Okay. So your calculator will help you. We're gonna talk about asymptotes again. All right? There's gonna be a discontinuous function or continuous. Right? Discontinuous means it's got a break in it, in your graph when you look at it. It's not all just one thing. All right? Continuous, just the opposite. It's all together, one thing. Most of these are discontinuous. Sometimes these will have a little hole in them. Okay? A spot where there's no number, this number doesn't work. So it's a break and we call it a hole. A rational function, again, is a function whose rule can be written as a ratio of two polynomials. We've talked about this. The parent function is f of x equals 1 over x. Its graph is a hyperbola, right? So these graphs are called hyperbolas. You got tickets for me?
I do.
Nice.
There's your free tickets
Okay.
for session 1 tomorrow. If you happen to get in, can get some more.
Yeah, that'll be for mom and dad, right?
And I don't know if they'll make you, they might say use the same code for these.
Okay, so that's
the
it.
code.
Okay.
I assume they're not gonna do that in case you need it.
All right. All right, thanks.
Yep, and then things go super well, and you guys are going out the next day. Get them with the, they'll probably do that code again.
Okay.
Use this for code.
Okay. All right, thank you. All right, so again, this is called hyperbola. You know, the U's and the upside down U's we call parabolas, right? Well, these are called hyperbolas, right? We'll learn more about those in chapter 10, but actually I don't think we don't do chapter 10. So. All right, so this is what a hyperbola looks like. It's two pieces to it. So this is a discontinuous because it's got two parts, not continuous. All right, but these dashed lines, this red dashed line and the green one, those are asymptotes. We talked about that very little, but that's a line that the graph approaches but never actually does what? Touches it. Okay? All right, so this is the graph of the function of 1 over x. So, you know, we could put that in our calculator at our y equals, just put 1 divided by x and hit graph, and you'll see the two, they're a little bit tighter, but that's this over here, okay? So what we're gonna have to do is figure out where our asymptotes are. So you gotta pay attention. There's lots of little rules today about these asymptotes, all right? Whatever makes the denominator 0 is always the vertical asymptote. And we'll talk about horizontal ones. They got different rules for horizontal ones, okay? All right, so this is our parent function, that 1 over x, all right? So if your function is written like this, a over, and that's going to be some number, over x minus another number plus a third number, you know, so this one we just looked at would have been 1 over x minus 0 plus 0 if we would have put the h and the k in there, okay? The vertical asymptote is always what makes the denominator 0, okay? That's like our restrictions we've been doing, right? That's always where the vertical asymptote is. Okay, Dave? Yep. All right. If you have a number out here, whatever that number is the horizontal asymptote, okay? In this one, there was no number out here, right? We could have put plus 0, but if there's no number, that means the horizontal asymptote is 0. That's the x-axis. Okay, what number makes that x 0? 0, right? So that's why the vertical asymptote was the y-axis. When x equals 0, you're on the y-axis, right? All right, so that's why, you know, if we wrote it in the form they just showed us, it's 1 over x plus, or actually x minus 0. Plus 0. That's why the vertical and the horizontal asymptote were 0 in that problem. They just never write it like that. They'll just write it like that. Okay? So again, vertical asymptote, horizontal asymptote. So when it's written in that form, you should be able to tell me just by looking at it. Does that make sense? So what's the vertical asymptote? Well, x plus 3, so what makes that 0 then? Negative 3, right? The value of x that makes it 0 is negative 3, right? So the vertical asymptote is x equals negative 3. The horizontal asymptote is y equals whatever that is, negative 3, right? Domain is which values again? X values. Range is your y value. Okay? So, vertical asymptote is x equals negative 3, whatever makes that 0. And our domain is x can be anything but negative 3. It's like our restriction. All right? It's the x value. My horizontal asymptote is y equals negative 2. My range is y cannot equal negative 2. Okay? Y can be anything but negative 2 is what that's saying for the range. Okay? So you can write, whatever you get for this, you just write x cannot equal that for the domain. And whatever y equals for your asymptote, you write y cannot equal that for your range. Okay? When you have to do a problem like that. So it's really easy when it's written like this, in this form. Okay? What number? Vertical asymptote. What number? 3. Horizontal asymptote. Negative 5. That easy. Okay? If you were to graph this, if it asked you to graph it, just go to your y equals 1 over, and put that in parentheses. That's important. If you don't, it thinks it's just 1 over x, it's thinking. So you got to put that in parentheses, all right? And then you can put your minus 5, and then you graph it. Okay? What dot is that going down? Right there. What number? 1. There. I know it's small. Let's do this. It's negative 5, right? You see that? 1, 2, 3, 4, 5. If I drew a dashed line through there, that's my, what do we call it? My what? The what? Horizontal. Okay? What number's right there on the X? 3. There's my vertical asymptote. You see that? That.
I thought you said that they never touched.
The graph never touches it. It's, it's, my lines are fat here and I didn't get it perfectly horizontal and the vertical.
Also,
The asymptotes can touch each other, but not, the graph won't touch the asymptote. Okay?
and what if X doesn't equal 3, then why is it on 3?
Yeah, that's X will never hit that, right? It gets really, really close, but it never actually hits it. That's why it's called an asymptote. Okay? So the dashed line means we're not really hitting it, right? When we did graphing inequalities, when did we draw a dashed line? Well, they were linear, but when it wasn't, it didn't have the little equal to underneath the radical, or the less than or equal to sign, remember? Okay, when we did a dash, that means we could, we got all the numbers up to, but not including the points on that line, right? So we're not really, when it's a dashed line like this, we're not really including X equals 3 or Y equals -5. Doesn't really exist in that graph. I just wanted to show you that those asymptotes are there. Okay, okay, again, we talked about this. Discontinuous function is a graph that has one or more gaps or breaks. The hyperbola graph in example 2 are discontinuous. A continuous one has no gaps or breaks. The functions you have studied before this, linear, quadratic, polynomial, exponential, logarithmic, are continuous. Okay, there was no gaps or breaks in those. Okay, all right, so here's a different looking one. Here's our function, x minus 3 times x plus 2 over x plus 1. The numerator of this function is 0 when x equals 3 or x equals -2. So you're going to get a function like this, and they're going to ask find the zeros. Okay? Whatever makes the top, the numerator 0, are called the zeros. Okay? And that's, again, what we did before with parabolas, where the graph will cross the x-axis. Those are the zeros. It's what makes the numerator 0. So positive 3, -2. So there's -2, 0, there's 3, 0. The marks are going by 2s. Right, Coli?
Right.
You're paying attention, right? You're not looking at your phone, right? Right. The vertical asymptote is whatever makes the denominator 0. So what number? -1. So that's why this blue dashed line goes through -1 on the x. That's my vertical asymptote. All right. When you put this in your calculator, make sure, if you have to graph it, you might not have to, but sometimes they ask you to graph it. Make sure you put parentheses around all your binomials. Okay? And if we put it in like that, it'll show this. It won't show the blue dash line, it'll just show the 2 red ones on your calculator. Okay? You with me? Okay, so how do I find the zeros again? Whatever makes the numerator, the top 0. Again, vertical asymptote, always what makes the bottom 0. Okay, so here's what they're saying. P is the top polynomial. Zeros are when the top polynomial equals 0. Vertical asymptote is always when the Q polynomial is 0, the bottom. Okay? That's all the P's and Q's mean, different polynomials. All right, so The vertical, we can do real quick. What is it? -3. What do I have to do first to figure out the zero? Factor this, right? Right, now that it's factored, what's the zeros? -4 and 1. Okay? So there's our zeros. Vertical asymptote, x equals -3. Okay, didn't ask us to graph it, so we're not even going to worry about graphing. I think maybe the next slide it asks us to graph it. Yeah, it says graph it then. So here's the picture of the graph of that one. Again, where could I get these values if I wanted to? My table, right? On my calculator. All right. Question so far? Is this making sense? All right, so to find the zeros, let's factor the top. There's no GCF. What are the factors of +6 that add up to 7? +6 and a +1, right? So the zeros are what?
-1.
You guys okay with that? And my vertical asymptote is -3, right? Again, it's x, I should say x equals, right? I should say x equals, -6, 0, -1, 0, but that's all you have to do. Once you learn the rules, it's pretty easy. You still got to be able to factor though, right? Any questions? All right, so here they did it, and then they graphed it, I think. I think it's here somewhere. Yeah, there it is. So they all look pretty much the same. They just kind of move right and left a little bit. Okay? -6, there's a 0, and -1. That's what we said, right? Some rational functions, including those whose graphs are hyperbolas, have a horizontal asymptote. The existence of and location of a horizontal asymptote depends on the degrees of the polynomials that make up the rational function. What was the degrees of that? 2. What's the degree of that? Not 0. 1. Number of degrees? Right? That's what we're talking about. It says, note that the graph of a rational function can sometimes cross a horizontal asymptote. So once in a while, our graph will cross a horizontal one. However, the graph will approach the asymptote when you get really, really big. Your x value gets really, really big. All right, so here's the rules. All right, for horizontal asymptotes. If the degree of p, remember, p is the top one, is bigger than the degree of q, the bottom one, there is no horizontal asymptote. P is the top one. What's that degree? 2. What's this degree? Q. 1. That's bigger. 2 is bigger than 1, right? There was no horizontal asymptote. Okay? When the degree of P, the top one, again, the top polynomial, is less than the degree of Q, the bottom one, the horizontal asymptote is y equals 0, which is the x-axis. Right? So if the bottom degree is bigger, it's the x-axis. Okay, Trent? When the degrees are the same, maybe they're both x squared, top and bottom. They're both x's, top and bottom. One's x cubed and another one's x cubed. All right? If they're the same, the horizontal asymptote is y equals the leading coefficient of P divided by the leading coefficient of Q. So if they're both 1x squared, what's 1 over 1? 1. If one is 2x squared and the bottom one's 3x squared, what's the horizontal? 2 over 3. Okay? That's all that's saying. So, bigger degree, smaller degree, is there a horizontal asymptote? No. All right? Factor it. I think this one's done. The work's done for you guys on this one. What are the factors of -4 that add up to -3? -4, +1, right? They didn't even do it for us. We'll do it. Okay, so there's my zeros. If it's just an x like this, it's 0. And there is no horizontal because the degree of the top, the numerator, was bigger than the degree of the denominator. Okay, graph using the graphing calculator. That's what it looks like. There's no horizontal asymptote. All right. Coli, what's the horizontal asymptote? Horizontal. There is one. What is it?
We gotta factor it out.
You can factor, but you don't need to factor to find what it is. For horizontal, what do you look at? What did we just talk about? We talk about degrees. Okay? What's the degree of the top one? 1. What's the degree of the bottom one? When the bottom one is bigger degree-wise than the top one, what's the rule? Ozer knows. She's been listening. What is it? Who knows it? Olivia? Olivia? What did we just say?
0. Yeah, I said it.
Hey! Look. If the degree of P, the top one, is less than the degree of Q, the bottom one, the x-axis, y equals 0. That's what happened in this example.
0.
So I'm giving you a quiz Monday. That's why.
What?
What's the vertical asymptote? No, that's a 0. There's 2 of them. Why is there 2 of them? Can I factor that like that?
Yeah.
Yeah. Right. So what are they?
-1.
Yeah. I think this has the picture of it. There it is. Horizontal was on x-axis. Vertical is 1 and -1. So that's what it looks like in your calculator. Okay. Sometimes it will cross the horizontal. This one crossed, it looks like. That's okay. So, learn those rules. That's all we're doing. We'll talk about the holes on, you can look this over and figure out well, I can do a hole real quick for you. What are the factors of this? 3 and -2, right?
Yeah.
When that happens, the hole's at whatever makes that 0. Where's the hole at? No, what makes that 0? +2. So you just draw a hole at it. You know how to graph this, what's the y-intercept? 3, what's the slope? What's the slope? 1 over 1, right? So that's where that line came from. And then right above the 2, you put the circle, the hole. That's all you gotta do for those. So, because you will have a couple hole problems for homework. Whoa, there you go.
Tough names.
Full line.
Why do you freeze on?
So the door.
Did your mouth say freeze?
I don't blame my dad. When I was sending my own.